So we have a car that is speeding on a horizontal road, a curve with radius of 70 meters. Okay. So let's start off with given. So the radius is 70 meters. Coefficient of friction here is 0.6. Height of center of gravity of the car from the road level is okay. So let me do this. Guys, for this question we have two parts, and the second part uses this. Say we have a car and the height of the center of gravity. So the car's center of gravity is somewhere over here. So this is around 0.4 meters. Of course, the car can be higher because the engine and everything, it's closer to the ground. So this is 0.4. And the distance between the wheels, or this distance, not that actually, sorry. This distance is 1.2 meter. And that's our center of gravity. So what is center of gravity? If you guys might not know. So this is from a different topic, and this you will be learning. If you're not learned, you'll be learning in time. So I'll just show you. It's not that complicated, but yeah, you need to understand a lot of concept. If not, the calculation over here is not a big deal. So that we will do, but conceptually I will not be making it very clear. But if you understand that topic, that is center of gravity topic, then it will make sense. The first part is quite simple. So part A, the road's limit, skidding. Calculate the maximum safe velocity based on the frictional force provided by the road. So we know that the frictional force provides the required force to negotiate the curve. So basically that's the source of your frictional force is source of Fc. And so I'm able to equate this. And we have to figure out V actually. For that, I can cancel this. And yeah, I know it's a direct formula. I'm just used to this. 70 and mu is how much? 0.6. 10 into 70. So this will be, okay, without calculator you'll end up with 4.2 10 root of 4.2 meter per second. 6 into 70, right? Yeah, 4.2. Square root of 420 is, people generally don't write this way. So this is supposed to be 2 root of 105 meter per second. You'll end up writing this way. Or if you have a calculator and if you're allowed to use, then you have a different answer. Different representation, same answer though. So that is the speed at which you can go without skidding. Okay, so you can write the statement. Speed without skidding is 2 root of 105 meter per second. Now we are looking at part B. Calculate the maximum safe velocity based on the car's geometry, which dictates the velocity at which the toppling torque equals the stabilizing torque. Okay, that statement, if it's not clear, it's okay. See, point here is, if you have a car, turning towards, say, right. Okay, so it's making a right turn. So two things are happening over here. One is your M into G, and other is your, this would be your centrifugal force. So how do I represent that? CF for you guys. So this is centrifugal. So what is centrifugal? As I mentioned before, I won't go to the detail. So the thing is, it's the play between these two. Okay, then you need to know the perpendicular distance and all of that. So for that, I need to consider on which all of this is happening. So this is the center, and that would be your line connecting center of mass, center of gravity with that of the wheel and stuff. These length will be your perpendicular distance, and this length is 0.6, and this is how much? 0.4 if I'm right. Okay, again, I know the diagram is a bit small, so let me zoom in a bit. So this is the diagram, guys. So that is, you need the perpendicular distance. So why do we need it, and so on and so forth, that you'll understand in time. So this is the funda. Okay, so the torque thingy, there's a concept torque, and you need to know this perpendicular distance and the force, and this causes it to basically topple, and the gravity keeps it stable. Okay, let me put it this way. Actually, this is the funda that I can explain at least. See, this centrifugal thingy force, it will try to topple the car this way, while the gravity will try to push it this way. So when these two are equal, these two forces or this rotating forces are equal, then the car will not toggle. If this exceeds, then it will toggle. Okay, so that's the funda. Very simple thing. So if you want, you can take a second. Try to say, if you have a box, try to topple it. I kept telling toggle, my bad. Topple it, try to topple it. That is, make it rotate, make it turn. So can you get a feel of it, that this at this point it pivots? Again, take a box, so it will go on the edge, along the edge, and then it will turn. Did you guys do that? So then this will make sense. So that's what we are trying to do. So basically we are trying to figure out, okay, what is the maximum, to what extent can I push? Okay, guys. So we'll equate the torque, equating torque due to your centrifugal force and gravitational force. So they counter each other and they stabilize. So we have mv square by r, same formula, but here the distance is 0.4, height, that is perpendicular distance. So let me write perpendicular distance. Perpendicular to what? That I can't explain, can't go to the detail. And this is equal to m into g, and this two here is perpendicular distance. So no, it will be confusing. So mass and mass gets cancelled. We are trying to figure out v square by, I'll substitute the values though. Radius is how much? 70. Perpendicular distance from this force. So basically from here, how far is this force? 0.4 is equal to 10 into, this is 0.6, right? Yeah, and this value will give us the answer. So 6 into 70 divided by 0.4, root of 1050, 32 point meter per second. Of course, without calculator, it will be 5 root of 42, guys. Okay, so yeah, will we be able to, because of, okay, let me put it this way. This part of the question is not there, but will we skid first or topple first? So this answer is 2 root of 105. This is actually 20. So this is approximately 20.5 actually meter per second. And this is 32. So yeah, we will skid before we topple. Okay, that's one more. So I happen to introduce a new concept over here for some of you at least. So the first part is quite simple. When will we start skidding? Right? To what extent can we go before which we'll start skidding? It's a simple 20 meter per second value. After this, we'll start skidding. Now we are looking at one more concept over here, but the source is similar to your centripetal, but here it's centrifugal. So centrifugal will try to topple you guys, that is make the vehicle turn, but because of gravity it's stable. It's happening even now. I mean, all the vehicles around you, whenever it's taking a turn, this is happening. So we are looking at the maximum possible value before which the vehicle topples. Again, vehicle is taking a right turn, so I need to put it in this way. So all I did was equate your same force, but perpendicular distance is what we are considering. That's the extra bit. If not, it's the same set of calculation and you have a different answer. And that's that. Okay, so you can pause and have a look.